This question, which appeared in Neet 2012, a proton carrying 1 MeV charge, that is proton, then alpha particle. Both are particle but having different charge and different electron. So charge of proton is equal to E and charge of alpha particle is equal to twice of E. And mass of proton is mp and mass of alpha particle is 4 times mass of proton. This is the standard result. As it is, we know what is if the particle is moving in a circular orbit, circular path, in that case the centripetal force of the particle, where we say with the R, where mass, velocity, radius of the orbit is equal to Q into V into B. Sin theta will come sin 90, which is equal to 1, or we can write R is equal to M V by Q into B, which is equal to P divided by Q into V. Why we call it as P? Mass into velocity is nothing but momentum. So we have derived the relation as already we have derived. As it is also we have derived, if a charged particle Q is accelerated through a potential difference of V, then its kinetic energy is equal to half into mv square. In the previous video we have already of mv square, which is equal to Q into V, where V is the potential difference. So we can see this one. So kinetic energy is equal to half into m square V square by m. This equation we add and multiply numerator and denominator by m square V m square by m is equal to k, or which this k is equal to half into m square. This is equal to half mv whole square by m. So this is equal to half into p square by m. As it is, we have done earlier also. Now again we are doing it. Therefore p square is equal to 2km, or p is equal to under root 2km. Why we are writing p is equal to under root km? Because in this question energy is given to us. Therefore p is equal to 2km. And what about r? R is equal to p divided by qb. So p is equal to under root 2km. P is equal to divided by q and b. Now here energy is moving in circular path of radius r. Radius is same. Both our particles are having the same radius r. And same magnetic field. Magnetic field is same for both. In uniform should be the energy of an alpha particle to describe circle of same radius and same field. It means radius is same and field is also same. So it means we can say R of alpha, we will talk about first R of proton is equal to R of alpha. What is R of alpha? So R of alpha is equal to, this is R, 2 into kinetic energy into m divided by qb. First we will write for alpha. Because R of alpha is equal to same, so the expression for us R is same, under root qb is equal to under root 2km divided by q into b. So this is for alpha per proton particle, proton. Okay. Now since the masses are different, kinetic energies are different, this root 2 can be cancelled. Since charges are magnetic field are same, this can be cancelled, and squaring both the sides. What is k? K into mass of alpha. What is the mass of alpha? Is equal to 4 times mass of proton divided by charge of alpha particle is twice, charge of alpha particle twice 2e under root, this is under root, is equal to, and here, what is this under root? So K for the proton it is given and 1 MeV, so we will write K of proton, this is K for alpha particle, it should be for alpha, 4 times of this mass, this kinetic energy for this one K of alpha, and mass is equal to, mass of alpha is equal to 4 times mass of proton, and this is kinetic energy for proton, into mass of proton, and divided by charge of proton. For proton particle it is mp, and charge of proton is equal to E. So we can cancel this and this, and squaring both the sides, K of alpha into 4 into mp divided by 4 is equal to K of proton into mp divided by, this already divided, so on squaring this will become 4, okay. Now we can cancel this 4 and this 4, and mp and mp, it means the result is coming K of alpha is equal to K of proton, and K of proton, that is kinetic energy of proton, is equal to 1 MeV. So kinetic energy alpha is asking, which is equal to 1 mega electrovolt. What should be the energy of alpha particle? The energy, that is kinetic energy of alpha particle, when it is describing this radius of circle of same radius in the same field, is equal to 1 MeV. So this is the right answer.